Hey, this is Dr. B again, and it's time for worksheet 7.4, double replacement reaction worksheets. If you need a periodic table, pull one out now. If you think you have things memorized, go ahead and do it. We'll be writing the products and balancing out these chemical reactions. There's a lot that goes into it. This involves naming things, this involves balancing, this involves recognizing charges. And when we do this, we'll be using the numbers 1 and above. We'll include the number 1 when it is shown to be only that many. Most scientists leave that out. Some teachers might take points off, but we'll put them there for clarity. And for the purpose of this worksheet, we'll assume that every reaction does in fact occur. That means we'll be ignoring such things as whether a precipitate actually forms, making sure this makes sense in terms of an activity series. This is simply a practice in double replacement reactions. So be aware that these are two little caveats before we begin, which we're going to do right now. If we mix lithium sulfide with silver nitrate, well, I guess we could make some lithium nitrate and silver sulfide, shown here. The ratio is 1 to 2 to 2 to 1. Make sure that makes sense. The things that were doubled up were the lithium and the silver. So we are going to have to use 2 of those, and we will make 2 of those. Barium chloride plus sodium carbonate will make barium carbonate and sodium chloride. NaCl is fine for sodium chloride. Barium carbonate will be also fine, so we're going to have to double up on the sodiums and the chlorides. I believe the only thing that will have a 2 of it in front of it will be the sodium chloride. So 1 to 1 to 1 to 2. Aluminum sulfate, hey, I don't want to see the answer yet. Aluminum sulfate plus sodium phosphate, well, that can make aluminum phosphate. AlPO4 should be good because I know aluminum is +3, phosphates are -3. And sodium sulfate, that's going to be Na2SO4. Since this is a 3, we're going to have to carry that out to 6. Once you do all the work, you'll find that we have aluminum phosphate plus sodium sulfate. And let's check it. 2 aluminums, 2 aluminums, 3 sulfates, 3 sulfates, 6 sodiums. 3 times 2 is 6 sodiums, 2 phosphates, 2 phosphates. Copper 2 chloride with phosphoric acid, also known as hydrogen phosphate, could make copper phosphate. Notice we always keep the thing in front, and we start with the cation here too, and hydrogen chloride. That'll be HCl. There's your copper 2 phosphate and your hydrogen chloride or hydrochloric acid. 3 coppers, good. 6 chlorides, yes. 6 hydrogens, yes. 2 phosphates, indeed. It's balanced. Copper 1 sulfate. I know that's copper 1 sulfate because I know that those 2 plus 1s will offset the -2 that a sulfate is, plus magnesium fluoride. Notice I don't have to specify the charge on the magnesium because it's in group 2, it's monovalent. Will form copper 1 fluoride, so CuF should be fine, and magnesium sulfate, and once again MgSO4 will be fine since +2 and -2 is good. We'll have to double up on the thing on the product that has fluoride in it and the thing that has copper in it, which is just the copper fluoride. So I believe it'll be 1 to 1 to 1 to 2. The only thing that needed to be doubled up was the copper fluoride. Aluminum chloride plus barium sulfate will make aluminum sulfate. Now you're going to need 2 of those +3 aluminums to offset the 3 -2 sulfates. And it'll also make some barium chloride, and it's not BaCl3. When you write these over on the product side, just write BaCl and then think about it. Students always, commonly pull that over. Now we do pull over the 4 right here. Why? Well, we'd only be writing 1 sulfate, but it happens to have those 4 oxygens. And we'll have to clean up barium chloride. I think it'll be BaCl2. There's our aluminum sulfate, and there's our barium chloride. Notice we needed the 2 aluminums to offset the 3 sulfates, and the only way to write 3 sulfates is using the parentheses. Old teachers sometimes say, wrap your radical, this being a radical. And here's your barium chloride. 2 aluminums, yes. 3 sulfates, yes. 3 bariums, yes. 3 sulfates, yes. Looks good. Sodium sulfate plus ammonium iodide will turn into sodium iodide. NaI is fine, and ammonium sulfate, NH4, need 2 of them, SO4, because ammonium's +1, sulfate is -2. Quickly, 2 sodiums, yep. Whoa! 2 sodiums, yep. 1 sulfate. Yep, just 1 SO4. 2 ammoniums, yep. See the 2? And 2 iodides, yes. 2 sodium iodides. That means 2 sodiums and 2 iodides. Okay, a little faster. Lithium phosphate and barium chloride will form lithium chloride and barium phosphate. Balanced out. Looks good. For instance, 6 chlorides, 6 lithiums. Yes, because of that 3-2 combination, you have to go out to 6. See if you can name these and say the 2 products. This would not be iron bromide, it's iron 3 bromide. This is hydrogen phosphate, but did you know that its common name is phosphoric acid? Hope so. And it will make iron phosphate plus hydrogen bromide. Zinc nitrate, do I need to put a Roman numeral after it? Most teachers, I think, would say no, because zinc is always +2. It's on the diagonal, they say. However, it is in the D block, so if you said zinc 2 nitrate, I think that's okay. And it is zinc with a +2 nitrate, right? And it reacts with barium hydroxide to make zinc hydroxide. That's your first +-, and the next +- would be barium nitrate. Make sure you keep zinc in its +2 form. Therefore, it needs 2 of the hydroxides. Barium also needs 2 of the nitrates. Interesting, that's how it all started. This one happens to be 1:1 to 1:1. This is our double replacement reaction worksheet.